Hello, my name is Simranjit Singh, and this is an overview of my second assignment for COM 251, which basically entailed me building an expression tree based implementation of a calculator. So we have four main files here, and we're gonna go over them one by one. So for binary node, we've seen most of this before, so I'm not gonna go too in depth here. So here, the main difference is that we're differentiating internal nodes, which we're gonna use to hold operators, from external or leaf nodes, which we're gonna use to hold operands. And one other thing here is that if it's an operator, the value of that node will be 0, and we're actually gonna calculate that later on in the evaluate method. So then we have the print in order, again, recursive methods. We've seen all of this previously. And here we have evaluate. So this is the method that's actually going to go through the expression tree and evaluate and give us back the integer result. So this is basically a recursive call in a post-order traversal. So we first call it from the left child and then the right child, and we actually evaluate the expression. To do this, we first check if the token is an operator. If it is, then we're going to check what the value, which operator actually is, right? So if the token is a plus, what we're going to do is before the value was 0, but now we're going to update that value to be the sum of the left and right child, and we're going to return that value. In a much similar manner, we're going to do the same thing for the minus and any other operator. We basically update the value, do the actual operation, and then return that value. If it's an operator and it's not one of these five, we're going to go over here. I mean, in theory, it should be impossible to execute this, but just in case we have this else statement just to catch. We're going to print out the identified operator, excuse me, and just return -1. Otherwise, if it's not an operator, we just return the value, the integer value of the operand. Here in expression tree, again, this is very similar to what we've seen before with binary trees, where we are building an expression tree with either an empty tree with no node and here with just one node. And then here we have the merge method, which we take the subtrees and then we merge them. The only difference is that the root here is always the operator, so you must make sure that the token that we're giving passing through to the merge is the actual operator. If it isn't, we print out that root should be an operator and return. And then here, this is the method that checks if a node is actually an operator. Again, very simple. We're gonna just check if it's one of the 5 operators we have. If it equals to any one of those, we're gonna return true. Otherwise, we return false. And here, what we're doing is basically calling the methods we defined in binary nodes for the printing, all the printings, and the evaluate method as well. So calculator, this is like the main bulk of the code. So first, what we do is have an expression tree, we call it XPA tree, and then a hash map called variable table. And so here we're just initializing both to null and like an empty hash map. And here run, public void run, which this is basically the main method of calculator. And the first thing it does is actually take the info file and read through the file. And here what we're doing is using a helper method I defined below. We're printing out the contents of that file just to on the console just to know what expression we're actually evaluating. And here we're going through and we're iterating through all the contents of the file line by line. And if the line has an equal sign, that means we're initializing a variable. And with your, we need to add this entry to our hash table. Oh, hash map, sorry. And then, so if it equals, if it has equal, then we have the line in the form of variable equals integer. What we do here is get a list of tokens. We're gonna split it on the white space, and then check. So first we want to check that if the length is not 3, right? If it's not variable equals integer value, then there's a syntax error. And also, if the variable name length is not just one character, maybe it's like a word like variable equals 5, then that's not allowed for this calculator. So if the length is not 1, that's also a syntax error. So if it's any of these two, then we just print out the syntax error, say the variable is not defined correctly. Otherwise, if the syntax is all good, what we're going to do is take initialize as 0, which is the actual variable name, and then we're going to add that entry with its actual value, which is in this case initialize at 2, right? Because initialize at 1, the middle value is just the equal sign right here, so we don't really care about that for this. And then after doing that for all the lines in the input file, the last line, which str now contains the actual expression, right? Because that's how the syntax for all the files is. And so we take that string infix expression, and then we pass it through string to expression tree method that's been defined below, and we get back the corresponding expression tree. And now we check if that expression tree is not null. We're gonna print out the result after evaluating it, and then after doing that, we're gonna clear the variable table. This is important to do because in test, as you can see here, we're going through all these test cases at once. So if you define a variable in a previous test case, that's going to be still in the memory for the following ones. So it's very important that we actually clear the variable table after every single run. So here is the aforementioned print file helper function. It's very simple. It just reads the contents of the file and reads it in by line by line, and then prints it out on the console line by line. And here is the main string to expression tree method. So we pass it the string infix expression, and then what I'm doing here is just following the algorithm that we discussed in class. So first we make a stack for expression trees called a tree stack, and we make another stack for our operands or operators, and we have these two stacks. And then how we did earlier, we're gonna split the input into a list of tokens, and we're gonna iterate through each token. So this is what we're doing right here. And so if the token is an operand, we build a tree with it as the root and push it under the tree stack. So how do we know that token is an operand? Well, it's not an operator. It's not an opening or closing parentheses. If that's the case, we're going to add it to... if that's the case, there's two different cases here then. That either the operand is a variable and its entry is in the hash map. If that's the case, we're going to make a new expression tree and get the token name and the variable and the actual value from the hash map, and then add the tree to the stack. Otherwise, operator is an actual integer. So we're first gonna check that if it's parsable, that means it's an integer. If it is, then we're gonna again create an expression tree with the name and the actual value, and then add it to our stack. And then otherwise, if it's neither of these two cases, that means the operand is not defined. So there's a syntax error here. So here we check if the token is a character, and I found this little method to do that on Stack Overflow by an answer from Adam. And here we're just checking the first the character, if it's the first character of the token, if it's a letter. If it's not a letter, that means it's a syntax error where we have a undefined operator or character. For example, we can have square brackets or curly braces, or maybe we have exponential like operator here, which is not allowed. So we print out this method and return. Otherwise, if it is actual character, that means this is a variable that has not been initialized before. If that's the case, we're gonna print out a variable. The variable name is not defined as the error message, and then return. Okay, so second case, if it's an opening bracket or opening parentheses, that means we push it onto the OP stack. So here we're just pushing it on there. And otherwise, if it's an operator, again, we're checking if it's an operator. If it is, and the stack is empty, we push it onto the OP stack. Otherwise, if stack is not empty, we need to pop the operators of greater or equal precedence. The way we do that was a lot simpler than what I first imagined, where basically we only working with two levels of precedence. Either we have plus or minus. If that's the case, that's the lowest precedence possible. Where in that case, we're popping all the operators. So as long as the stack is not empty and the next element or value on the stack is an operator, we pop it. And then here we just hold the value, and here we're going to check if we have at least two subtrees. If we don't, there's been a syntax error somewhere, and we return no. Otherwise, we continue. So we pop the two subtrees, we hold the value t1, t2, and then we create a new expression tree t, and then we're going to merge the expression trees with the operator as the new root. Here you might notice that we're doing t1 and t2 in the opposite manner. This is because we're working with a stack, and then the order gets reversed. So we're reversing it back to actually get the correct answer. And after doing that, we just add this back to the tree stack. And at the end, we actually need to push the the operator onto the OP stack on the current token. I originally missed doing this when I was working on this, and had to come back to the next day, realize that I just misread the algorithm. And if you don't do this, everything breaks. So this is very important. Okay, the other case is that it's one of these three operators. This means we only pop operators of the same precedence. So while it's not empty and it equals one of these three, we're gonna pop again, do the same method. If it's less than 2, syntax error. Otherwise, pop the two subtrees and then merge them. And again, push it afterwards. So the other thing the token could be is a closing bracket. So if it is a closing bracket and the OP stack is empty, that means there is a syntax error. There's no opening matching bracket on the stack. If that's the case, we print out syntax error and return. Otherwise, we're gonna pop operators until we find the matching opening bracket. If we get to this if statement, that means that we've peeked at the last element, and the last element is not the opening bracket. That means there's a syntax error and the brackets are unmatched. Therefore, we print this and return null. Otherwise, we pop, and again, checking if we have two subtrees, less than two subtrees, then we again do a syntax error. Otherwise, again, do the same merge with the OP as the new root. And at the end, we're gonna pop the opening bracket from the OP stack. And at this point, hurrah, we've reached the end of the infix expression. And now what we do is pop all the operators in OP stack. So while it's not empty, we pop it, and again, do a little sanitary check here that we actually have the required subtrees. If we don't, we return this. Otherwise, we take the two subtrees and then merge it into a new tree with OP as the root, and then add it back to the stack. So at this point, we're done doing the whole conversion, and we should be left with one tree on the tree stack, which is now the full expression tree. So if that's the case, that's good. We done our job correctly, no syntax error, and we just return the tree stack to the run method, expression tree to the run method. Otherwise, if we reach this part, there's a syntax error. Maybe we have like multiple trees left on the stack. In that case, we again print an error and then return null. And here are the two helper methods I was using. So isOP is basically a copy and paste of the expression tree, one we saw before. Found it very useful, so I copied it over here as well. Returns true if token is an operator. And this is parsable, as I'm actually able to find online, again on Stack Overflow, by this user. And I've linked to both the web page, the photo links for the two articles in the README file, just in case you want to check them out. But basically, it tries to parse the integer. If it can, it returns true. And if it can't, it gets the number format expression, whereas like we don't actually give it an integer value to parse, then it returns false. And here, the final file, already 13 minutes, so I'll try to wrap it up fairly quickly here. And here we're just, we're reading all these command line arguments, and then we're gonna just go through all of them. So given all of these and these C cases, I've added extra just to catch errors that the other ones weren't catching. So we're just running it 20 for all the inputs. So let's see the fruits of our labor. So so we begin by, this is the expression, right? So we're printing out the expression and then the result. So all of these, so this is all correct. So we have 3 times 3 is 9. Here the same expression, we're dividing by 2. So when Java does division, we just truncate at the integer value. So the answer is 4.5, 9 divided by 2, but we just take the 4. And here, ask that you trust me that I actually did look through all of these, and these are the correct integer values. And here, the more interesting expressions were the syntax errors. So here the error we're catching is here. We have an unary operator, -4, which is not allowed, only this is not allowed for our calculator. Here we have no closing bracket matching, and here again no opening bracket matching, and here again, right, as I said that we can only have round brackets. Square braces are not allowed. Here again P and Q are defined. But C is not defined, so we return this as the error message, and similarly here F, QP are defined, but F is not. And here again, I was talking about how a variable used to be only one character. Here, although everything looks good, the variable name is 3 characters, so we say it's not been defined correctly. Here again, not allowed, and here we're catching that, oh, we can't take x to the power y. That's not one of the 5 operators we're using. Here, x equals 5, but the 5 is on the next line, so it's not defined properly. The 5 should be here. And here, just to make sure, if we give the calculator 9, it actually returns 9. All good. Here we do capital S equals 2 equals 4, lowercase s equals 2, so we take the mod, the result is 2, right? 4 divided by 2, remainder is 0. And here capital S is 5, lower s is not defined. And here variable s is not defined. Here I was talking about earlier about clearing the hash map. If we didn't do that, then this would have resulted in s equals 2, which would have been incorrect, right? So that's why we were clearing that. And this little thing helped me catch the error. So here again, 2y equals 6. It's not allowed. This should be just y or just some other variable. And here again, we're just passing through an expression. Result is 7, sorry. And this is, I'm just checking just to make sure we're catching all the brackets errors. So here we have around the bracket here again. So here it's actually reading is invalid OP. And this is actually giving the syntax error because if you notice here, there's no space, right? So it's reading open bracket 1 as 1 token. That's why we have invalid OP. Whereas here, when we have the space, we actually get the error for this bracket. So this actually is catching this error right here, whereas this is catching this over here. Again, bracket here, get the syntax error. And although this looks like a mess, I promise these brackets are balanced. So we just get 1 plus 2 equals 3. And here, although the brackets are balanced, they're not correct, they're not allowed, right? Because curly braces are not allowed, so we do that. And here I was just checking, making sure, right, we're actually calculating the proper expression. So with the brackets, the result is 0. With the brackets, it's 5. And here as a final test, because I realized that I didn't use minus anywhere, I think, or I need to test, just do 2 minus 1 equals 1. And that is 70 minutes. Sorry for the longer video, but I wanted to be a bit detailed. And so that will be all, and thank you for listening. Bye-bye.